So today we're going to cover Chapter 11, Section 4, and we're going to talk about three-dimensional figures. So the first slide has the definition of a polyhedron, and a polyhedron is a solid that is bounded by polygons called faces. In your polygon or your polyhedron, in your solid, you're going to have edges, you're going to have vertices, and you're going to count those vertices, edges, and faces. The faces, again, are all the polygon sides. So in the case of the cube, it would have 6 faces, and those faces would all be squares. The edges are going to be the segments that are formed by the intersection of 2 faces. So where 2 faces meet, it forms an edge. The vertices are going to be the intersection of 3 or more edges. So those are those pointy corners I showed you. Plural of polyhedron is polyhedra or polyhedrons. This particular picture down at the bottom, notice the shape that I have 2 of is a trapezoid. I've got a trapezoid face right here in the front, and then I've also got a trapezoid face back here in the back. So it's the shape that you have 2 of. So if it asks you to name this figure down at the bottom, this would actually be a trapezoidal prism. All right, so these are the different types of solids. So on the left side, the blue figures, those are polyhedra. Notice all of the faces are polygons. So the top picture is an example of a rectangular prism. And then the bottom could be a rectangular pyramid. When they don't give us anything about the side lengths that they're congruent, I can't assume that they're congruent and say that it's a square pyramid. I would say it's a rectangular pyramid. The other side, the green shapes on this slide, these are not polyhedrons because they have curved sides. So whenever there is a curved edge or side there, and the faces are not polygons, then these are not polyhedrons. But they do have specific names. The first one is a cylinder, then a cone, and then a sphere. Coming up after spring break, we will actually calculate the volume and surface area of all of these solids. So to name a prism, you're going to name it by the shape of the base. And again, you have to be careful. Sometimes when they give you the pictures of these prisms, they may not be sitting on their base. So what you're going to look for is the shape that you have 2 of. So in this particular example here, notice the top and the bottom. I have 2. These are both pentagons. So this would be an example of a pentagonal prism. The lateral faces in this picture are parallelograms. They also look like they're rectangles. It all depends on the shape, but the lateral faces will be parallelograms that are formed by connecting the corresponding vertices of the bases. You will also have a height or an altitude of your prism. And remember, the height will always be indicated by a right angle because it's the perpendicular distance between the bases. And then the 2 bases are always going to be 2 congruent polygons in parallel planes. So once we start calculating the volume and the surface area, we're going to need to locate some of these dimensions, and we're going to need to locate the height, and notice that it will be next to a right angle because it's perpendicular. So a pyramid, whenever we want to name it, we would name it by its base, and it's going to be, the base will be a polygon with n number of sides and n number of lateral faces that meet at the vertex. So for example, if I have a square pyramid, I'm going to have 4 sides on my square, so I will also have 4 lateral faces, which will be triangles. The altitude will be the segment from the vertex straight perpendicular down to the base. So the altitude is generally going to be drawn inside, and it'll be indicated by a little right angle. and that would be your height. And again, the base shape here, as long as they give me congruency marks, I could say it's a square. But in this case, because I don't have any congruency marks, I would say that this is a rectangular pyramid, because I don't know if all 4 of those sides in the base are congruent or not. And again, you will name the pyramid based off the base shape. Lateral faces are really all those triangle sides, and there are actually 4 lateral faces here because there's 4 triangles, and then the 1 rectangle base. So this pyramid has 5 faces. The next slide actually has a theorem. It's not in our textbook. It was in earlier textbooks that I had. It's called Euler's theorem. I will not test you on Euler's theorem, but it's a nice little way to check your counts. So if you count the number of faces, vertices, and edges, to make sure that your counts are correct, you can add your number of faces plus vertices. It should equal edges plus 2. So notice in my cube, I've got 6 different square faces. I've got the 2 sides, the front and the back, and the top and the bottom. And then I also have 8 vertices. So remember, these are the little corners here. So I have 8 of those, 8 vertices. And then my edges are the intersection of the 2 faces. So I have an edge here, 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 so 4 so far. And then I've got the 4 around the top, and then the 4 around the bottom. So I have a total of 12 edges. So if you wanted to check your count, add faces plus vertices, it should equal edges plus 2. 6 plus 8 is 14. 12 plus 2 is 14. So this is a way I can confirm that I did count the faces, edges, and vertices correctly. Again, I will not test you on Euler's theorem. It's just a little tool you can use. So now let's just do some examples. So the first example wants us to tell whether the solid is a polyhedron. If it is, name it, and then find the number of faces, vertices, and edges. So the first one, notice all of my faces are polygons. I don't have any curved sides. So this is a polyhedron. And so yes, it's a polyhedron. And the specific polyhedron type that it is, notice the congruency marks along the base. These are all congruent sides, making this a square on the base. And it's coming up to the point, that vertex. So this is a square pyramid. Now I need to count how many faces it has. So the faces, it's got 5 of them. It's got 4 lateral triangle faces, and then it's got the 1 square base. So a total of 5 faces. So 4 triangles and 1 square. Then the edges, now let's do vertices first. Vertices, I've got 1, 2, 3, 4, 5 vertices. And then lastly, the edges. And my edges go down 1, maybe I'll do them, oh, they're showing up. 2, 3, 4, 5, 6, 7, 8. So I have the 4 around the square base, plus the 4 going up to that top vertice. So I have a total of 8 edges. And again, if you want to use Euler's to check it, you would do faces plus vertices should equal edges plus 2. So faces were 5, vertices were 5, edges were 8, and then 5 plus 5 is 10, 8 plus 2 is 10. So a little way to check your counts. The next figure, however, is not a polyhedron. Notice the curved side here. So it does not have polygon sides. So this one is not a polyhedron. Now, here's what I'm referring to in figure C. Notice this shape, the shape that I have two of. I have two triangle faces, and then I have three rectangle faces. So the face that you have two of is going to be the name of the prism. So because I have two triangles, this is a triangular prism. It's not sitting on its base, it's sitting on its side, but you're looking for the shape that you have two of. So my faces, I have 5 of them because I have two triangles, and then I have the 3 rectangles. I've got a rectangle right here, then I've got another one back here, and then I also have the one on the bottom. So I've got one here along the bottom. So I have 3 rectangle faces, giving me a total of 5 faces. Now for my edges, or vertices, all right, let's count vertices now. So for my vertices, I've got 1, 2, 3, 4, 5, 6 vertices. And then the edges are the intersection of the faces. So over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 edges. And again, you can check it by doing faces plus vertices equal edges plus 2. So 5 plus 6 equals 9 plus 2, and you get 11. So 11 equals 11, so it works. All right, next we're going to talk about a cross section. And this is going to be the intersection of a plane slicing through a solid. So basically what they want to do is think about the plane as being like a saw, and you're cutting off part of the solid. And then if you were to pick up the piece that you cut off, what shape do you see? So in these color pictures, the cross-section shape that you would see is the dark purple. So here, when I slice through this triangular pyramid, notice the shape of my base here is a triangle. So the name of this pyramid would be a triangular pyramid. And the cross section where this plane is slicing through, this cross section shape is a triangle. Now, depending on where you are slicing through, you're going to get different shapes based on the solid. And we're going to see that coming up on the last slide when we slice up a cube in different spots. So here it wants us to describe the shape formed by the intersection of the plane and the solid. So the plane is the pinkish red, and then the original solid is blue, and the cross section is the purple. So figures A, B, C, and D, the original figure on all of them, they're cubes. When we do the cross section for A, and they take that plane and slice it, that cross section, since the original shape was a cube, the cross section for A is a square. Then when they slice it diagonally, then this purple cross section becomes a rectangle. The original shape was still a cube, but the cross section is now different because the plane is slicing it in a different spot. Notice in figure C, it's still the cube, but now they're trying to slice off part of that corner, and then that would be a trapezoid. And then if they just try to slice off the little corner, that cross section is a triangle. We're looking at the purple. And then the last section, or the last one, figure E, this shape is a cone and its cross section is a circle.